Welcome back, everyone, to another deep dive.
From AI-inspired insights from farmers.
If you're enjoying what we're doing here, we'd love to hear from you too.
Absolutely.
Hit that like button, subscribe to the channel, and definitely leave a comment telling us what you want to see more of on this deep dive.
We're always looking for new ideas, and we really value your feedback.
So what farm-related mysteries are you dying to uncover?
Right.
What questions are keeping you up at night? Let us know, and maybe we'll tackle them in a future deep dive. All right, welcome everyone to another deep dive. Today we're tackling a topic that's been generating a lot of buzz, and rightfully so, the energy dilemma of AI.
Yeah, it's fascinating stuff, really, especially for those of you out there maybe exploring new ventures, maybe even thinking about something like farming. Because energy consumption, sustainability, these aren't just abstract concepts. They're becoming super relevant in just about every sector, impacting decisions in ways, well, you might not immediately realize.
Exactly. And that's why we're here to dig into some recent reports that have been making the rounds. They detail the energy demands and the environmental impact of these advanced AI technologies. And frankly, some of the findings were pretty surprising.
It's all about getting a grasp on the underlying resource footprint, right? Because AI is booming and it's leaving a mark. We're going to navigate the central challenges here, the trade-offs we're seeing between this rapid technological progress and the significant considerations for our climate. Ultimately, we want to see what the data really reveals about this complex interaction.
Our goal today is to cut through the noise, distill the essential information for you. We've got reports from The Guardian, Hacker Noon, Humane Technologies, IMD, all top-notch sources. And we'll break it down without getting too bogged down in the technical weeds.
We've got 3 key objectives for you today. First, we want you to understand the sheer scale of energy consumption by AI during development and deployment. Then we'll look at how they're currently trying to measure its environmental impact and, importantly, the limitations of those methods. And finally, we'll explore some potential paths towards more sustainable AI development. And all of this, as you mentioned, is increasingly relevant for resource management, environmental responsibility, no matter what you're focused on, even, as you said, modern farming practices.
Okay, so let's start with the basics, the energy requirements of AI. I think it's easy to think of AI as this purely digital thing existing in the cloud or whatever. But the reality is it's underpinned by a very real, very physical infrastructure.
Absolutely. When we talk about training large AI models, the ones constantly making headlines, we're talking about processing immense data sets. And that happens in data centers. These are huge facilities packed with powerful servers, specialized hardware like GPUs. These GPUs are power-hungry by design, optimized for parallel processing, which is perfect for the complex calculations AI relies on. These machines run around the clock, often at very high capacity.
To give you an idea of the scale, the training of ChatGPT-4 reportedly consumes something like 7,200 megawatt hours of energy. To put that into perspective, that's enough to power a small U.S. city for an entire year. And the kicker is, this energy demand isn't just a one-time thing during the training phase.
Right, it's ongoing. Even when you're just interacting with an AI, asking it a question, that seemingly simple action triggers a cascade of energy use. The AI has to sift through mountains of data to generate a response. Imagine searching a massive, constantly updated library in milliseconds. That's essentially what's happening.
And this increase in energy use is not insignificant. For instance, Google's AI-powered search, it reportedly uses 10 times the energy of a conventional search. Now think about how many searches happen globally every second. The numbers add up very, very quickly.
But all this activity is having a direct impact on infrastructure. The AI boom is driving the construction of new data centers all over the world to handle this enormous computational workload. Goldman Sachs, they're predicting 160% growth in data center power demand by 2030. It's a staggering projection.
Which leads us to something we found quite interesting in our research, this idea of creative accounting when it comes to emissions. And it all revolves around renewable energy certificates, or RECs. It suggests companies might be presenting a greener picture than what their actual operations reflect.
Right. So major AI companies are trying to address the emissions from their data centers, right? And one of the key tools they're using is the purchase of these RECs. They're essentially tradable commodities, proving that 1 megawatt hour of electricity was generated from a renewable source. But the criticism is that simply buying a REC, well, it doesn't guarantee that the specific electricity powering their data center is green. It might not even lead to additional renewable energy being generated, hence the creative accounting label.
So it's like they're offsetting their emissions by buying these certificates. But it doesn't necessarily mean they're directly reducing their carbon footprint at the source. It feels a bit symbolic.
The idea is they're purchasing renewable energy, wind, solar, whatever generated elsewhere. But, and this is crucial, buying a certificate doesn't mean that specific energy is powering their data centers. Often they're still drawing power from the local grid, which in many places is heavily reliant on fossil fuels.
So if a data center is powered by burning natural gas, but they buy a REC for wind energy generated hundreds of miles away, well, those carbon emissions are still happening at the data center.
Precisely. As one report put it, we can achieve net zero by combusting fossil fuels in one area and procuring renewable energy in another and claiming zero impact. That carbon still ends up in the atmosphere. And this is where the Guardian's investigation was really revealing.
They did some great work digging into the numbers, and they found a pretty significant discrepancy between the emissions these companies were reporting and their estimated actual emissions.
Yeah, on average, the real emissions from the data centers of companies like Google, Microsoft, Meta, Apple, they were estimated to be 7.62 times higher than what they reported. That's a huge difference.
And some companies had particularly large variations, right?
Right.
Can you give some specific examples?
Absolutely. So Google, their estimated data center emissions were about 2.7 times higher than reported, Amazon around 5.6 times. But then you have Microsoft. Their actual emissions were estimated to be a whopping 21 times higher than claimed. Apple, even more staggering, 402 times higher. And Meta, get this, 3,100 times higher than their reported figures. 3,100 times. It really makes you question the accuracy and transparency of the reporting mechanisms.
Wow, that's really something. Beyond these discrepancies, what's the overall picture of energy consumption for these companies? I remember the total figures were pretty eye-opening.
They were. So in terms of annual electricity consumption, Google tops the list at 25 terawatt hours. That's equivalent to the electricity usage of 2.3 million U.S. households annually. Microsoft is close behind at 23 terawatt hours, which is enough to power 48 Disneyland Paris parks for a year. Meta comes in at 15 terawatt hours, Apple at 3.5, and even NVIDIA, though smaller in this group, uses 0.6 terawatt hours annually.
And collectively, these companies account for a significant portion of the total U.S. electricity consumption.
Right. Combined, they use about 1.7% of all the electricity consumed in the U.S. That's comparable to the total electricity consumption of entire countries like Austria or the Czech Republic. It really puts the energy footprint of these AI companies into perspective. So we've talked about the energy hunger of AI. Now let's look at the other side of this coin, the climate impact. This is where technology and climate really clash.
Yeah, AI has this immense potential, but clearly it comes with an energy cost and therefore an environmental impact. So how do we reconcile this tension between technological progress and our climate goals?
That's the core question, isn't it? AI holds a lot of promise for tackling environmental challenges, optimizing energy grids, monitoring deforestation, even making agriculture more efficient. But the development and deployment of these technologies, as we've seen, contribute significantly to carbon emissions and resource depletion. It's a real dilemma.
Let's look at the carbon footprint specifically. The training of these large AI models seems to be a particularly energy-intensive process.
It is. Training a single large AI model, one with, say, 175 billion parameters. These are like the adjustable knobs that the AI learns from that can consume roughly 12,287 megawatt hours of electricity. And that translates to about 502 metric tons of CO2 emissions. Imagine the emissions from driving 112 gasoline-powered cars for a whole year. That's the equivalent.
And that's for just one model. We know there are countless models being developed and refined all the time. A study from a few years ago by the University of Massachusetts Amherst, if I recall correctly, painted a pretty grim picture.
Yeah, that 2019 study estimated that training a single AI model could produce over 626,000 pounds of CO2. It's like the lifetime emissions of 5 average cars. These figures really highlight the environmental cost of creating these sophisticated AI systems.
And it's not just the training. Even generating content with these AI models takes a surprising amount of energy, especially with the rise of generative AI.
Absolutely. Think about those models that generate realistic images or text, like Stable Diffusion XL. To generate just 1,000 images with a model like that, it can emit as much CO2 as driving an average car for over 4 miles. It might seem small on its own, but consider the sheer volume of images and text being generated every day. The cumulative impact is significant.
And this high demand for computing power also has financial implications, driving up the cost of these AI services. But it's not just energy consumption and carbon emissions. Water usage is another major factor that often gets overlooked.
Right. Data centers, those essential hubs for AI, they need massive amounts of water, primarily for cooling, keeping those systems from overheating. And the numbers are pretty staggering.
Can you share some of those water consumption figures just to give us an idea of the scale?
Sure. Google, they use a whopping 24 million cubic meters of water annually. That's enough to fill over 9,600 Olympic-sized swimming pools. Or think about it this way, 120 million bathtubs. Microsoft uses about 7.8 million cubic meters, which is enough to fill 9,000 Boeing 747s. Apple comes in at 6.1 million, Meta at 3 million, and NVIDIA at 134,000 cubic meters. These are vast quantities of a precious resource. It's one thing to look at these massive numbers, but when you think about it in terms of communities facing water shortages, it really hits home.
So we've got high energy consumption, potential underreporting of emissions, massive water usage, and on top of all that, the growing problem of e-waste from AI technology. All that hardware eventually needs to be replaced.
Exactly. AI, like any electronic device, contributes to the growing mountain of e-waste, and this waste often contains harmful substances, heavy metals, things that can contaminate our soil and water, posing serious risks to both human health and the environment. The World Economic Forum, they predict that global e-waste will reach over 120 million metric tons by 2050, so responsible e-waste management and recycling, those are absolutely crucial.
So it's a multifaceted environmental challenge. And then there are the financial implications to consider.
Right. Even just running a service like ChatGPT, conservative estimates put that at around $100,000 per day. That could balloon to $40 million per month as usage grows. And the whole ICT sector, including this burgeoning AI infrastructure, it already accounts for about 2% of global CO2 emissions. And that number is only going to rise as AI expands.
So we've laid out the problem. Now let's talk about solutions. It's not enough to just identify the challenges. We need to explore potential ways forward.
Absolutely. And there's a growing awareness of these issues, which is encouraging. Gartner, for instance, outlines 5 key approaches to developing more sustainable AI. One is what they call making AI as efficient as the human brain. It involves using network structures that mimic the efficiency of our own brains. They refer to it as composite AI.
That sounds promising. How does that work in practice?
It's about combining different AI methodologies, knowledge graphs, causal networks to solve problems more efficiently, potentially using less computational power compared to relying solely on deep learning models. Another strategy is putting your AI on a health regimen. That's all about monitoring energy consumption throughout the machine learning process, stopping training when improvements plateau, keeping data localized when possible, reusing pre-trained models, and using more energy-efficient hardware.
Makes sense. Optimizing the training process itself to reduce waste. What are the other recommendations?
The third strategy is to run AI in the right place and at the right time. This means considering the carbon intensity of the local energy grid when running AI workloads, distributing data center workloads across different locations, optimizing energy usage, and using energy-aware job scheduling systems that can track and forecast carbon emissions. The fourth strategy is buying new clean power where you plan to consume it. This is about using power purchase agreements, PPAs, and RDCs that actually add new renewable energy capacity to the grid in the regions where the energy is being used. So focusing on additionality, making sure that more renewable energy is actually being generated.
And the fifth.
The final recommendation is to make environmental impact a key factor in AI use cases. This is about prioritizing AI applications that create genuine value over those that could be harmful to the environment, continuously improving the energy efficiency of existing AI initiatives, and avoiding investments in AI use cases that could have significant negative environmental consequences. It's about being thoughtful and responsible in how we develop and deploy AI.
So there are some concrete strategies being proposed, which is good to see. Our research also touched on some of the initiatives that major tech companies are starting to take in this area.
Yes, a number of these companies are starting to address their environmental footprint. Google, for example, highlights its commitment to efficient practices, which have reduced the energy needed for training AI models, leading to lower emissions. They also point out that their data centers are more energy efficient than typical enterprise data centers, and they're implementing climate-aware cooling technologies and responsible water management practices. Plus, Google's exploring how AI can be used for environmental benefits, like reducing traffic congestion.
And Microsoft is making some notable efforts too, especially on the clean energy front.
Definitely. Microsoft has committed to a future powered by zero carbon energy. Their chief sustainability officer has even said that AI can help them achieve these goals by identifying new ways to reduce carbon and improve access to renewable energy. They're also looking at using AI to streamline the regulatory process for new nuclear power plants, and they've even partnered with a fusion energy startup that aims to deliver fusion power by 2028. And they're focused on making AI training more efficient, for example, by using textbooks as a training source instead of relying solely on massive data sets from the internet.
So it seems like it's going to take a multi-pronged approach, not just the tech companies, but policymakers and individuals as well.
Absolutely. Google stressed the need for collaboration between policymakers, urban planners, business leaders, and everyday people to truly unlock AI's potential in a sustainable way. Policymakers have a key role to play in promoting data sharing, making sure technology is accessible, and supporting the development of climate-related skills. We all have a part to play in steering AI towards a more environmentally conscious future. And this whole discussion about AI's energy challenges and the push for sustainability, it actually has some interesting parallels with other sectors. You mentioned farming earlier, and it turns out there are some surprisingly direct applications of these same principles in agriculture.
As we wrap up the main part of our discussion, I did want to offer a little bonus insight, especially for those of you who are new to farming or thinking about starting a farm. It might seem like a big leap from AI energy consumption to agriculture, but the core principles of efficiency and sustainability, they're surprisingly interconnected.
Yeah, the scale might be different, but the fundamental ideas are the same. Reducing energy costs, maximizing true climate benefits. And for those of you venturing into farming, particularly with a focus on sustainability, there are practical, often low-tech solutions that can have a huge impact.
So what's the big takeaway for new farmers who want to be both cost-effective and environmentally responsible?
It all starts with soil health. Healthy soil, rich in organic matter, it acts like a natural carbon sink, pulling carbon out of the atmosphere. This means you need less synthetic fertilizer, which is very energy intensive to produce. Plus, healthy soil holds water better, so you might not need as much irrigation, which also saves energy. It's a win-win, good for your bottom line and good for the planet.
It's fascinating how the soil can actually help capture carbon. What are some specific practices that new farmers can use to build healthy soil?
Practices like cover cropping and no-till farming are really effective. Cover crops protect the soil, add organic matter, and reduce erosion. No-till farming minimizes soil disturbance, which helps store more carbon and saves fuel because you're not tilling. And then there's agroforestry, which is basically incorporating trees into your farming systems. Trees provide shade, which can reduce cooling costs in some cases, and they sequester more carbon and boost biodiversity.
So a really good first step for anyone starting out in farming would be to focus on soil health.
Absolutely. We'd recommend that even small-scale farmers prioritize understanding their soil, getting it tested, and then adopting practices that build up that organic matter. This is a foundational strategy for reducing energy costs associated with inputs like fertilizer and achieving genuine, tangible climate benefits right there on your land, going beyond offsets to have a direct, positive impact on the environment.
Well, this has been a really insightful deep dive into the energy dilemma of AI, with some unexpected but valuable connections to other fields like agriculture. To sum it all up, it's clear that the rapid development of AI presents a significant energy and environmental challenge. There's a lot of energy consumption, a complex landscape of potentially hidden emissions, and different levels of energy efficiency among the major players.
That's right. But along with these challenges, we're seeing growing awareness and a lot of innovation aimed at creating a more sustainable future for this powerful technology. The strategies being explored range from making AI algorithms more efficient to transitioning to cleaner energy sources for those data centers.
And as we just discussed, understanding these large-scale energy and environmental dynamics can help us make more informed decisions in any resource-intensive field, including modern sustainable agriculture. The key principles of efficiency, transparency, and striving for a real environmental impact, those apply across the board.
And this leads us to a final thought for you as you consider new ventures. How can the lessons learned from the energy dilemmas of cutting-edge technologies like AI inform your approach to resource management and sustainability from the very beginning? How can you ensure that your efforts contribute to genuine environmental benefits rather than relying on indirect offsets? How can you build sustainability into the foundation of your work, creating a truly sustainable path from day one? Thanks for joining us on this deep dive. It's been a real pleasure exploring this topic with you.
Likewise, thanks for having me.
And to all our listeners, keep learning, keep exploring, and keep pushing the boundaries of what's possible in agriculture.
Hitting that like button and smash that subscribe.